Hello students, welcome back to another algebra video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Alright, we are asked to graph the inequality in a coordinate plane, and that's what the graph is. That's a coordinate plane. So what we're going to do is, step one is to graph the boundary line. So let's put this in the form of y equals mx plus b. If I subtract x from both sides, I get y is less than or equal to negative x plus 4. So that means the boundary line is y equals negative x plus 4. Let's graph this on our graph. The 4 tells me that the y-intercept is 4. And the negative tells me that the slope is negative 1 or negative 1 over 1. So I'm going to rise negative 1. I'm going to go down 1 over 1. And I'm going to draw a line through these 2 points. Now it's a solid line because we are less than or equal to. Now step 2 is to test a point. So we'll test 0, 0 because it's easiest. So that was step 1. Step 2 is let me plug 0 into the original equation. The point 0, 0, that means that x is 0 and y is 0. So I have 0 plus 0 is less than or equal to 4. Is that true? Is 0 less than or equal to 4? Yes. Yes, it is. So step 3 is to shade the side with 0, 0. We're going to shade the side, the half plane, with 0, 0, because that point satisfied our inequality. It is a solution to our linear inequality. Yay! Nice review from yesterday. Now, today, we are going to jump into section 5.7. 5.7 is systems of linear inequalities. So in 5.1 through 5.4, we looked at systems of linear equations. In 5.6, we looked at linear inequalities. So now we're kind of going to combine the first part of chapter 5 and 5.6 together. Now we're going to have systems of linear inequalities. So today, our learning target is I know what a system of linear inequalities is. I know what they are. And the success criteria is that you can check solutions of systems of linear inequalities. So we're going to start off nice and easy today, just really trying to wrap our minds around what is a system of linear inequalities. So let's start with that. What is a system of linear inequalities? Well, a set of 2 or more, we might get into the or more in a future video, but not today. A set of 2 or more linear inequalities in the same variables. It's basically the same thing as a system of linear equations, only instead of equal signs, we have inequalities. So instead of equation number 1 and equation number 2, I have inequality number 1 and inequality number 2. But we still have 2 or more of them, and they are still in the same variables, which means that if I use x and y in inequality number 1, I'm also using x and y in inequality number 2. So, very, very similar to systems of linear equations, just with inequalities this time. So, what is a solution of a system of linear inequalities? Well, a solution to a system of linear equations was a point or an ordered pair that was a solution to both equations, that satisfied both equations. A solution of a system of linear inequalities is an ordered pair that is a solution of each inequality in the system. So the solution of a system of linear inequalities is very similar to a solution of a system of linear equations. So for example, this is an example right here. A solution of the following system of linear inequalities is -2, 5. So if I plugged in -2 for x and 5 for y in both of these equations, I would get true inequalities. I would get true statements. Okay, let's kind of put all of that together and do a little recap. A system of linear inequalities is a set of 2 or more inequalities, and here is an example of one. And a solution is an ordered pair that is a solution of each inequality in the system. Now, I want you to think, and we're not going to talk about this explicitly today, but I'd like to get you thinking about it. In section 5.4, we explored the number of possible solutions for a system of linear equations. We said that there could be one point where the lines cross, there could be 1.1 solution. If the lines were parallel, go in the same direction, never crossed, then there was no solution. And we said that if the lines were indeed the same line, that they were lying right on top of each other, and they were the same line, that there were infinitely many solutions. So what do you think? How many solutions do you think that we're going to have for a system of linear inequalities? Can there be only one solution? Is there going to be infinitely many solutions? What do you think? What do you think? And what would we need? What would it look like? What would it look like for a system of linear inequalities? What would the graph of that look like? And what would a different number of solutions look like? What would it look like for there to be no solutions? What would it look like for there to be infinitely many solutions? We're not necessarily going to talk about that today. That's a future video, but I want to get you thinking about that. See if you can make some guesses about the answers to those questions. Now let's get into an example checking solutions, because that was our success criteria for today, that you can check solutions of inequalities. So, of a system of linear inequalities. So tell whether each ordered pair is a solution of the system of linear inequalities. So we're going to do the same thing that we did in 5.1, which is we're going to take x and we're going to take y. We're going to plug them in to both of the inequalities and see what we get. So let's do inequality number 1 first. We have y is less than 2x. So we have 5 is less than 2 times 3, because x is 3. And 5 is less than 2 times 3 is 6. Is 5 less than 6? Yeah, yes it is. So this point works for inequality number 1. Now we need to check inequality number 2. Y is greater than or equal to x plus 1. We're going to give ourselves some space. Okay, so y is blue, and it is 5, and we want to know, is 5 greater than or equal to x plus 1, greater than or equal to 3 plus 1. 3 plus 1 is 4. Is 5 greater than or equal to 4? Yes, 5 is greater than 4. So, we will say that 3, 5 is a solution. It is a solution because it satisfies both of our inequalities. Wonderful. Let's move on to part B, and let's look at inequality number 1. Ooh, actually, pause the video, try this one on your own. Try part B on your own, see if you can check whether the ordered pair is a solution or not. Then, let's do it together. So, inequality number 1 is y is less than 2x. Here, x is -2 and y is 0. And we want to know, is 0 less than 2 times -2 is -4? Is 0 less than -4? Nope. No, it is not. So we don't even need to check inequality number 2. We don't have to. We already know that because inequality 1 doesn't work, the point -2, 0 is not a solution. Because remember, even if it works for one of them, if it doesn't work for one of them, it's not a solution. Let's check inequality number 2, though, just to get some more practice. Remember, you don't need to do this. We're just going to get some extra practice. So we have 0 is greater than or equal to x plus 1, and x is -2. So we have 0 is greater than or equal to -2 plus 1 is -1. Is 0 greater than -1? Yes. So this point works for inequality number 2, but because it doesn't work for inequality number 1, not a solution. Okay, let's check our answer. So substitute 3 for x and 5 for y. We have 2 check marks, so it is a solution. That's what we got. And for part B, substitute -2 for x and 0 for y. We got something that was not true, something that was true. So the point -2, 0 is not a solution of the system. Aha! We were correct. Okay, that is all I have for you today. I wanted to start off nice and easy, just understanding what a system of linear inequalities was. It's very similar to equations, but it is a little bit different, and we're going to see that more in future videos. So, now is the time to rate yourself, assess your understanding of the learning target and the success criteria. Are you horribly confused about systems of linear inequalities? Can you check solutions of systems of linear inequalities, or are you totally lost? Are you getting there? You think you know what's going on, but you know maybe you don't have a lot of confidence, or are you ready to rock and roll? This made total sense to you, and you're ready to go out, do the homework, do the next lesson. And whatever you are on your scale of 1 to 3, take the appropriate action. Ask questions, try the homework, or help your friends, depending upon what you're ready to do. These are some practice problems that you can do to practice the skills that you have learned in this video. The first set of problems, we didn't do an example explicitly like this, but I want you to see if you can understand what's happening in this graph, and would these points be a solution? What does the shaded part of this graph mean? Why is this only like a quarter plane, not a half plane? Why isn't it a half plane? These are questions to ask yourself before the next video. And of course, the second set of practice problems is just like example 1, so you can do those to practice the skill that you learned in example 1. And as always, we're going to end our video with a launch. This launch comes from John Dewey, and he says, "Education is not preparation for life. Education is life itself." Now, when I was in high school, I did not believe this. I believed that education should be preparation for life. When I was in high school, I was like, nobody's teaching me how to file my taxes. Nobody's teaching me how to buy a house or budget anything. Like education, like school, kind of pointless. It's just hoops you gotta jump through to get what you want out of life. When I was in high school, I thought education should be preparation for life. That's it. End of story. As I'm getting older, I'm realizing that I do believe education is life itself. When I think about what I want out of my life, I want to travel and I want to be able to communicate with people in the countries that I want to travel to. I want to learn to speak Spanish fluently. I want to learn to speak Japanese fluently, more or less fluently. I want to learn more so that I can learn more about people's cultures. I can travel. I want to become the best teacher that I can be. I want to get really good at my job. And that requires learning. That requires continually educating myself so that I can become better at learning languages, teaching, whatever. I want to learn how to eat better and how to exercise so that I can stay in shape. That is education. So typically when we think about education, we just think about school and going to school. But I want to encourage you to think about, like, where does learning appear in your life? And is there anything that you want out of life that's going to require you to learn something? If you want to eventually record your own album, you're going to have to learn maybe how to play an instrument, maybe how to harmonize with yourself or with another person, maybe like how to record music, how to mix it together, all that stuff. You're going to need to learn. And so the more that you can get better at, improve on your learning, the more that you can understand how to learn, the more that that's going to help you with the things that you really care about in life. Maybe you don't care about history. That was me in high school. Maybe you don't care about math. That was a lot of my friends in high school. But learning how to learn is going to benefit you very much in life, because life and the things you want out of it is going to require that you learn something and that you keep learning throughout your life. So, education is life itself. I truly believe that, and I hope that you will explore where learning fits in with the things that you want out of life, and maybe take your classes more seriously. Focus on how to learn so that you can be a lifelong learner and get everything that you want out of life. So, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.